Hello, and welcome to Sleeping Among Stars, a calm place to drift through real cosmic stories at an unhurried pace, where the universe feels vast, the facts feel steady, and the night can soften into sleep. Tonight, we are going to settle into a phrase that can sound alarming. On first contact, a phrase that often travels through headlines like a warning label on a dark bottle potentially hazardous. When people see those words attached to an asteroid, the mind tends to do something natural and a little dramatic. It imagines a rock already aimed at Earth, a countdown already running, and a danger already certain. But in astronomy, potentially hazardous does not mean doom. It does not mean impact is expected. It does not even mean impact is likely. It means something much more specific and in a quiet way much more manageable. It means the object meets a set of criteria that tell astronomers it deserves careful tracking because its orbit comes close enough to Earth's orbit and its size is large enough that if an impact did happen in some future scenario, the consequences could be meaningful. The label is not a prophecy, it is a filing category. It is the universe being treated responsibly, not fearfully. And the calm goal tonight is to understand exactly what that category means, how it is defined, why it exists, and why it is actually a sign of a system doing its job watching the sky with patience and math rather than with panic. To begin, it helps to remember what kind of place the solar system really is. In everyday life, the sky can feel like empty space with a few bright lights pinned to it. But the solar system is not empty. It is a neighborhood filled with leftover material from its formation. There are planets and moons, of course, but also asteroids, comets, and fragments of many sizes all orbiting the Sun on paths shaped by gravity. Most of these objects live in stable regions like the asteroid belt between Mars and Jupiter, or the Kuiper belt beyond Neptune. But some have orbits that bring them closer to the inner solar system, closer to Earth's neighborhood. Those are called near-Earth objects, a broad category that includes asteroids and some comets whose orbits come near Earth's orbit. Near here does not mean near in the everyday sense. Even near-Earth objects are usually millions of kilometers away when they pass by. It means their orbital paths can bring them into the vicinity of Earth's orbital distance from the Sun. It means encounters are geometrically possible. And once encounters are possible, careful tracking becomes wise because Earth is moving too, and the long clockwork of gravity can produce close approaches over years, decades, and centuries. The phrase potentially hazardous asteroid, often shortened in technical context to PHA, is a specific subset of near-Earth objects. It is not a claim that the object is about to hit. It is defined by two main ideas: how close its orbit can come to Earth's orbit, and how large the object is usually inferred from its brightness. The closeness measure is often expressed with something called the minimum orbit intersection distance, the MOID. The MOID is exactly what it sounds like, the minimum possible distance between the asteroid's orbit and Earth's orbit, considering the shapes of those orbits. It does not necessarily mean the asteroid will be at that minimum distance at the same time Earth is there. It is a geometric measure, like saying two roads on a map cross at a point, even if two cars on those roads would not necessarily arrive at the crossing at the same moment. An asteroid can have a small MOID and still never come near Earth at any specific time, depending on timing and orbital phase. But a small MOID tells astronomers something important. The asteroid's path as a curve around the Sun comes close enough to Earth's path that future close approaches are possible. It is a "this deserves attention" flag, not a "this is happening" alert. The second idea in the potentially hazardous definition is size, because size strongly influences impact consequences. A small object can enter the atmosphere and burn up or produce an airburst with local effects. A larger object can survive deeper into the atmosphere and deliver more energy. In many public discussions, size becomes tangled with the word hazardous, as if anything labelled hazardous is enormous. In reality, the threshold for being considered potentially hazardous is often around the scale where the object is large enough that if it hit, it could cause significant local or regional damage. The exact thresholds can be expressed in different ways, and astronomers often use an absolute magnitude value, which is a measure of intrinsic brightness. Brightness is not size by itself, because brightness depends on reflectivity. A dark object can be larger than it appears, and a bright object can be smaller. But brightness gives a first estimate. When better measurements are available, like infrared observations or radar size estimates improve, the key idea is that potentially hazardous is reserved for objects large enough to matter.
Look closely at the
close
cyan
enough in
highlighted
orbital
area.
geometry
The
to
pattern is
warrant
stabilizing.
monitoring.
Confirm.
If you take those two
Running a
ingredients
comparison
together,
now.
the label becomes much less emotional. It is a category that says this object is not just a tiny pebble, and its orbit is not far away from Earth's orbit in a geometric sense, so it belongs in the group we watch most carefully. That is all. It does not say impact is
Risk
imminent.
is
It does not
uncertainty.
say impact probability is high. It does not say a collision will happen in our lifetime. It is a sorting method for a large catalogue, and the catalogue is large. Astronomers have discovered many thousands of near-Earth objects, and among them a subset meet the potentially hazardous criteria. Most of them will never hit Earth. They are simply on watch because their orbits come close enough and their size is large enough that the responsible approach is to track them, refine their orbits, and keep the uncertainty small. Now, to see why this matters, it helps to understand what risk means in the language of orbital mechanics. Risk is not just about what could happen, it is about probability and uncertainty. The moment an asteroid is discovered, we do not know its orbit perfectly. We know it from a set of observations points of light measured against a background of stars taken at
Follow-up
specific times.
observations.
From those
New
points,
points
astronomers fit an orbit.
Orbit
But early
begins
on,
to
the observation
converge.
arc can be short, maybe a few hours, maybe a night, maybe a few nights. With a short arc, many possible orbits can fit the data almost equally well. That means there is uncertainty in the asteroid's position and velocity. When you project that uncertainty forward in time, it grows. A small uncertainty in speed becomes a larger uncertainty in position months or years later. In the language of orbit determination, the future position becomes not a single line, but a cloud of possible positions. If that cloud overlaps Earth at some future date, the calculated impact probability can be non-zero. This is often when headlines appear because people see a non-zero probability and interpret it as danger approaching. But non-zero in this context often means we need more data. As more observations come in, the cloud shrinks, and the probability almost always drops to zero. That process is not the asteroid changing its mind, it is human knowledge becoming sharper. This is why potentially hazardous is not about certainty, it is about prioritization. Among the many objects in the sky, which ones deserve the most careful tracking so that uncertainty does not grow large? The ones whose orbits come close to Earth's orbit and whose size is large enough to matter. This is a practical and calm logic. It is like a weather service paying more attention to a storm system that might drift toward a populated area than to one that is moving out to sea.
Potentially.
Not because the storm is guaranteed to strike, but because if it did, the consequences would be greater, and therefore monitoring is justified. There is another layer to this story that makes it even more reassuring. The most common outcome of careful monitoring is not a narrow escape. It is the elimination of uncertainty. Many potentially hazardous objects are tracked so precisely that their positions decades into the future can be predicted with great accuracy. Sometimes an asteroid that initially appears on a risk list is removed quickly because new data rules out impacts. Sometimes an object remains on a risk table for a while because the uncertainties are stubborn, perhaps because the object is faint or because it is temporarily unobservable due to the sun's glare. But over time, as additional observations extend the arc, the orbit becomes known. The hazard becomes a matter of geometry and measurement rather than fear. The label remains, but the risk becomes clearer, usually smaller. It can be helpful to picture how a near-Earth object is discovered and tracked, because the process itself is calming. Survey telescopes scan wide areas of the sky night after night looking for moving points of light. When they detect a candidate, it is reported, and other observatories can follow up. Those follow-up observations are crucial. Each new measurement pins the orbit more tightly. Sometimes astronomers can find the object in archived images from previous nights or even previous years, where it happened to be captured without being recognized. These are called precoveries, and they are like discovering an old footprint that extends the trail. Precoveries can shrink orbit uncertainty dramatically because they lengthen the observation arc backward in time. Radar observations, when possible, are even more powerful. Radar can measure distance and velocity very precisely, turning a fuzzy orbit into a sharp one. Not every object is accessible to radar, but when it is, the orbit knowledge can become almost comforting in its precision. Now let us explore the word hazardous itself, because it carries emotional weight. In ordinary language, hazardous means dangerous. In the technical term, potentially hazardous asteroid. Hazardous is used in a conditional sense, hazardous if impact occurred. It is not stating that impact will occur, it is stating that the object is in a class where impact would not be trivial. The potentially is doing real work here. It means capable of being hazardous under a certain scenario, not currently hazardous in an active way. The difference is like the difference between a mountain and an avalanche. A mountain has potential energy. It is not an avalanche until conditions align. In the same way, a potentially hazardous asteroid has the potential for serious consequences if it were to impact, but that is not the same as being on a collision course. This brings us to the most common misunderstanding. People assume potentially hazardous means coming close soon. In reality, the label is about orbital geometry over time, not a specific imminent approach. Many potentially hazardous asteroids pass by Earth at safe distances and will continue to do so. Some will not come particularly close for decades. The label does not mark a countdown, it marks a membership in a monitored set. Another misunderstanding is that potentially hazardous objects are rare and therefore terrifying. The truth is that there are enough near-Earth objects that it's normal to have a substantial number in monitored categories. It reflects the richness of the solar system's debris population. It does not reflect an increase in immediate danger. In fact, having a large catalogue is a sign of progress. The more objects we know, the fewer surprises. Early detection and tracking reduce risk by giving us time and clarity. Time is in many ways the real theme of planetary defense. Movies often show last-minute heroics, a mission launched in panic, a deflection attempted with little warning. Real planetary defense is the opposite. It is slow, quiet, and based on early detection. The earlier you discover an object, the more options you have. A very small change in an asteroid's velocity applied years or decades in advance can translate into a large missed distance at the time of a close approach. This is because orbits amplify small changes over time. The best defense is not an explosion. The best defense is time plus measurement. And the potentially hazardous label is one way of ensuring that time and measurement are applied where they matter most. There is also a subtle reason the potentially hazardous category exists. Gravity is patient and sensitive. Orbits are not fixed in stone forever. Over long timescales, close encounters with planets can alter an asteroid's orbit. Even a close pass that is perfectly safe can change the asteroid's future path. This is not because the asteroid is unpredictable in a chaotic sense, but because small differences in a flyby distance can produce different outcomes after the encounter. One of the most interesting concepts in this field is the gravitational keyhole. A keyhole is a small region in space during a close approach such that if the asteroid passes through it, Earth's gravity nudges it onto a path that leads to a future impact on a later date. The keyhole can be very small compared to the scale of the flyby. But because the stakes are high, scientists pay attention to whether the uncertainty region includes the keyhole. If it does, they track more carefully. Often as the orbit becomes known, the keyhole is excluded and the concern disappears. Again, this is not doom. It is the careful management of a sensitive geometric situation. It is like monitoring a ship passing through a narrow channel. Most ships pass safely, but you pay attention because the channel is narrow, and consequences of an error would be large. Now, it may help to address another calm truth: impacts do happen
Look closely
on
at
Earth's
the cyan
timescales,
highlighted
but
area.
the largest
The
ones
pattern
are
is
rare.
stabilizing.
Earth has been
Confirm.
struck many
Running a
times over
comparison
its
now.
history. Craters on the moon and other worlds tell us that impacts are part of the solar system's story. On Earth, erosion and plate tectonics erase many craters over time, but the history remains. Smaller objects enter Earth's atmosphere, frequently often burning up
Risk
harmlessly.
is uncertainty.
Medium-sized events are rarer, but still occur on human timescales. Large, globally catastrophic impacts are extremely rare. The planetary defense effort focuses on the objects that would matter most if they hit, because those are the ones where early detection and tracking are most valuable. The potentially hazardous category is a tool in that effort, not a message of impending doom. It's also worth noticing how the language of NASA and other agencies is designed to be conservative and transparent. If there is uncertainty, it is published. If there is a small probability, it is tracked. If an object meets criteria for closer attention, it is categorized accordingly. This transparency can sometimes make the situation feel scarier to people who are not used to scientific risk reporting because it shows possibilities rather than certainties. But transparency is a form of safety.
Observations.
It means the public record is
points appear.
updated as knowledge improves.
Orbit begins
It means there is a
to
trail of
converge.
data and reasoning. It means surprises are less likely to hide. The potentially hazardous label is part of that transparent system. It says we are not ignoring this, we are watching it. Now let us do something soothing and practical. Imagine how you would explain this label to someone who is worried using simple and calm language. You might say potentially hazardous is like saying a storm system is in a region where it could reach land and it has enough strength that it would matter if it did. It does not mean the storm will hit. It means the system is worth monitoring closely. You might say it's a category for tracking, not a prediction of impact. You might say most objects with that label will never hit Earth, and many are tracked so well that we can predict their distance for decades. You might say if there were ever a real risk, we would know long before it was close because these objects are watched. The goal is not to dismiss concern, but to put it into the right shape. Concern that leads to awareness is healthy. Panic based on misunderstanding is not. As the night continues, we can deepen this into a quiet story about how science turns a potentially frightening concept into a manageable one. Imagine a newly discovered asteroid. At first, it is a few dots of light across a few hours. Its orbit is uncertain. A monitoring system checks whether its uncertainty cloud intersects Earth at any future dates. Perhaps there is a tiny intersection so it appears briefly on a risk list. Headlines might say it is on the risk table, but then follow-up
Potentially.
observations arrive. The arc lengthens, the orbit tightens, the uncertainty cloud shrinks away from Earth. The risk probability goes to 0. The object remains in the catalogue, perhaps still categorized as potentially hazardous because its orbit can come close and its size meets the threshold, but it is no longer a practical risk. This is the common pattern. The system looks scary only if you freeze it at the first uncertain moment. If you watch the full process, it is calmer. Uncertainty appears, then it's resolved. Sometimes the resolution is slower. Sometimes the object becomes hard to observe because it moves into the daytime sky. Sometimes it is faint, sometimes weather interrupts follow-up. In those cases, the object may remain on risk tables longer. But even then, the correct interpretation is not doom. It is we need more data. And the moment the object is recovered and measured again, the orbit tightens. The sky becomes more predictable. This is the rhythm of near-Earth object tracking. It is not a suspense thriller. It is a slow collaborative project. Now, because we are telling this for Sleeping Among Stars, it is worth allowing the story to carry a gentle emotional shift. The phrase potentially hazardous can be transformed
More
from
known
fear
objects
into a kind
means
of
fewer
quiet
surprises.
respect. It is a reminder that we live in a solar system where small worlds move around the sun, where gravity shapes paths that sometimes come near our own. It is also a reminder that we have become a species capable of watching these paths. We can detect faint objects millions of kilometers
The probe
away.
approaches the
We can
ancient
compute
asteroid,
orbits.
slowly
We can
revealing
predict
the secrets
close
held within its
approaches.
cratered
We can
surface.
refine uncertainties. We can plan. That ability is a kind of modern protection, not by force but by knowledge. Knowledge turns surprise into forecast. Forecast turns fear into preparation. Preparation turns hazard into manageable risk. And there is one more calming thought: the very existence of the label shows that the system has boundaries, that the sky is being organised into categories, not unlike a library organises books. A library does not label a book because it is dangerous. It labels it so it can be found again. Potentially hazardous is a shelf label. It means this belongs in the set we keep checking.
A tiny,
It means we
precise
want
window
this
region
easy
near
to
Earth
retrieve,
where the
easy to
planet's
update,
gravity
easy
can
to
alter an
monitor.
object's path.
It is the opposite of neglect. Neglect would be the real danger. Attention is the remedy, and attention is what this label represents. As we move toward a quieter end, imagine the night sky as it actually is, filled with stars that are unimaginably distant and steady, and also filled with nearer travelers' asteroids that are too faint for the naked eye, moving silently in sunlight far beyond our atmosphere. Most of them will never be noticed by anyone. Some are noticed by surveys catalogued, tracked, and given labels. Those labels can sound dramatic if you do not know the context, but the context is calm. The label potentially hazardous is part of a cautious, transparent system designed to reduce uncertainty. It does not mean doom. It means this one meets the criteria for careful tracking. It means we are paying attention. It means the math is being updated. It means the sky is not a mystery we fear, but a neighbourhood we map. And that is the final resting place for the mind tonight. Not in anxiety, not in a countdown, but in the quiet confidence of understanding. Potentially hazardous does not mean an asteroid is coming for us. It means its orbit can come close enough that it is worth tracking carefully, and its size is large enough that it would matter if it ever did. It means the system is doing what it should, watching, calculating, updating, and sharing. It means the universe is being handled with patience, and under that patient attention the night can feel a little softer, the sky a little more familiar, and the mind a little more willing to drift. Thank you for spending this slow journey with Sleeping Among Stars. If you want to continue resting, imagine those silent stones circling the sun, each one following gravity's rules, each one steady while Earth continues along its own path, calm and protected beneath a sky full of stars.